Hi students, welcome to LTX classes. This is me SPR. Today we're gonna see part of the geography concepts by me SPR. We're gonna see a detailed concept of the topic called asthenosphere. What is it? Asthenosphere. So which is the most important topic? See here, whenever I include a topic for your UPSC preparation, I will be including the topic that is most relevant for your prelims perspective. And also here, whenever you study different topics, some topics even after you are studying you'll prone to make mistakes. Such an important concept will be dealt by me. So here this asthenosphere is more important in UPSC prelims and mains perspective. We're gonna deal with it in detail. So here I'm gonna teach this in two forms. One is image oriented understanding, then concept oriented understanding. So first we shall learn based on the image, then we shall get into the concept and theory part that is required for our understanding. Yes, here. Okay guys, first of all, what is this asthenosphere? So how the word has been discovered? Asthenos. So asthenos means, which is a Greek word which means weak. So actually which means weak or not having strength, not having strength. So this is the original meaning of the so-called asthenosphere. First of all, what is asthenosphere? Let us learn that through images. Here this is a structure of the earth. So whenever you are studying the internal structure of the earth, so the most sensitive part, you are prone to make mistakes, and also you will be feeling difficult to understand. That part is asthenosphere. So that is the part today we're gonna discuss. See here, whenever you see surface of the earth, you find oceanic crust. There is a oceanic crust which is a very thin layer, not that much thick, but this is dense. See here, how is the oceanic crust? This is thin. Okay, this is thin but dense. Okay, this is dense. And also if you see continental crust, so this is continental crust which is thick, but less dense. So this will be less dense. How it could be, sir? How could you say that it is less dense? See here, oceanic plate gets underneath and continental plates gets over it. Here, see here carefully. So this oceanic crust gets underneath the asthenosphere. This will be subducted. So here oceanic crust is subducted inside the asthenosphere. So whenever we read plate tectonics, everything will be dealing in as a concept. If you want in detail, we can get it through our geography classes. So but first of all, let's understand this. So here earth's crust. So below, so combining of, so oceanic crust, if you combine oceanic crust and continental crust, so oceanic and continental, both the crust combined we call as earth crust. So both of them combined we call as earth crust. So below the earth crust, so here now we know where is the earth crust. So this part is called as the earth crust. Generally we divide a earth into, so earth's interior into different sections, that is crust, okay, crust, mantle, okay, crust, mantle and so called core. But many of you get confused. Actually what is this a lithosphere? What actually is a lithosphere, sir? Here for that I will provide a clarity here guys. So here look it over. Earth crust, below the earth crust there stays a upper mantle. What is it? Upper mantle. So upper mantle. So when you combine the earth crust and upper mantle, both are combinedly called as the lithosphere. Okay, so lithosphere means below the earth crust, upper mantle, both are combined called as the lithosphere. Below the upper mantle there lies a liquid layer called as asthenosphere. What is it? Asthenosphere. So this is some sort of semi-liquid and viscous liquid. So below the asthenosphere there will be so-called lower mantle. What is it? Lower mantle. So now you will have a clear idea. Asthenosphere is part of mantle. Okay, now so below the lithosphere there lies the so-called semi-liquid or viscous fluid. Sir, viscous fluid means what? What are you saying about viscous fluid? What does it really mean? So viscous fluid means, do you know honey guys? Do you know honey? So just think of it. If honey flows, how do it flow? It flow viscously. So the honey, when you are dropping it or when it flows with viscous. So it is an example of viscous fluid. Okay. So here next. So if you come and divide these such things, lithosphere is mostly rigid, which means which will be solid state. But asthenosphere is plastic. This is the characterization of the so-called asthenosphere, which will be little plastic, means some sort of liquid or semi-liquid. And next, core is liquid and also solid is okay. Inner core is solid. But here, many of you get confused. So if temperature increases when you go inside, so it should go on and melt down. Okay, so on core is liquid, I'm satisfied. How here there is a solid state and above the solid state there is a asthenosphere. Here temperature is less compared to the so-called asthenosphere. Why? So the all the doubts of yours will be cleared through this video. Let me provide that. Before that, you need to understand what is convectional current. Okay, after understanding the convectional current, I will say how the convectional current happens inside the mantle or so-called asthenosphere. Everything you understand the concept and understand the implication and understand the importance. Okay, here what is convection? Convection means if you take a bowl with water, you start boiling. See here, the surface will be heated. Here, due to heat, the surface will be heated. Whenever the heated water rises up. So you hear the sound called boiling. So you hear the sound of boiling and water boils. So then when it reaches the surface, then again after cooling it gets down. Again it heats, it ups up. Again it gets down, ups, down, up, down, up, down, up, down. So the continuous cycle is happening. This is called as, see here, red color indicates the warm molecules and the blue color indicates the cool molecules. So warm molecule rise up, cool molecules goes down. So completely this process goes on, goes on, goes on. This is called as a convectional current. If you understand this convectional current, come let's get to the how convectional currents are happening in the asthenosphere or part of mantle. Yes student, see here, automatically this asthenosphere is hot. So when hot, it rises up. So when after it rises up, it faces the so-called lithosphere and just it goes cools down. After cooling down, it gets down. Again, the convection creates same thing, goes down and comes down, goes up and comes down, goes up and comes down. Continuously this current is happening inside the mantle. So this is happening inside the mantle, so that only this convectional cells are formed. So this convectional cells means, see here, you can see here. So continuously this goes on happening. So you read plate tectonics. So here plate tectonics. Plate tectonic means what? Plate tectonics means there is a floating slabs of lithosphere. The lithosphere act as a floating slab on the earth. Okay, this is floating on the asthenosphere. So how it could move? The plant, see, so-called plate tectonic movement is proven by the so-called convectional cells. See here, so it rises and moves on. So based on the movement, see here, if the convectional cell, the convectional current inside the asthenosphere or mantle when moves in a opposite direction to each other. So here both move opposite direction to each other. Here this image, clearly observe this. If both moves opposite side to each other, then there is a point. This point is called as the divergent plate. What is it? Divergent plate, because both the plates, the surface lithospheric plates are moving away from each other. Both are moving away from each other. So here there is a divergent plate has been formed, and also where you can prevalently find oceanic ridges. So you had a clarity in understanding this. Okay, then if both the convectional currents move inwards, see here, both the convectional cells, convectional current move inward direction towards each other, both are moving towards each other, then both combine, see, both the slabs combine, clash with each other, and here forms a convergent, what is that? Convergent plate is formed. So convergent plate is formed. So guys, without the movement of plate, there is no survival on the earth. So without a movement of plates, there is no survival on the earth. Then this movement is possible only presence of asthenosphere. So without the asthenosphere, you can say that there is no life. Yeah guys, there is no life on the earth. Such a important this is. Okay, next image I will show you here. So as I had explained this image, no issues. This is how here slab pulls. See here, because of a conventional current, the slab will be pulling towards the direction the conventional current flows. Okay, no issues here. And next here, as I had said, this also I had explained in clear. See here, mostly see here, the thickness of the continental crust, which is very less. The ocean crust is very less, and continental crust is very high. Okay guys, so and also I need to say something for you. See here, there is a Moho discontinuity. What is Moho discontinuity? Moho discontinuity means it is a layer between crust and mantle. It is a change between crust and mantle where there will be a change in the so-called composition of the materials. So there is a layer called as Moho discontinuity between them. Okay guys, we shall read it later, discontinuities. So we'll come to the detailed study or theoretical study of the so-called asthenosphere. Now you'd have understood what is asthenosphere, everything in detail, and whatever image oriented study that you need to read and understand, everything you'd have had a clarity. Now let us come to the topic called why. So why a liquid? Actually, why this asthenosphere is a liquid stage and the temperature is high. So as we know that the temperature in the asthenosphere is more than 1300 degrees Celsius, and it may range up to 1700 degrees Celsius. So obviously this high amount of temperature means all the materials over there will be melted. So now here comes the doubt. So prelims also they may ask such types of question. What is the source of? There will be a confusion question for you. So here, what is the source of heat in asthenosphere? One thing, see here, primordial, okay, primordial heat. So first one thing is primordial heat. You need to know what is this primordial heat. So as I had said that, so asthenosphere gets it heat or energy. So always the earth inner core or energy present inside the earth is due to the primordial heat. What is this actual primordial heat? Primordial heat means, always remember one thing guys, here earth. So you know earth when formed, earth 4.5 billion years ago, before the formation of the earth 4.5 billion years ago. So the earth will be like a fireball. So earth is like a fireball. So it is heavily heated, large and huge amount of heat is present over there. Slowly top layer melts. So top layer cools down. So top layer slowly cools down, top layers cool. But what about the inner layer? Inner layers have the same heat. Inner layers have the heat. Inner layers have the heat. So the same heat is present over there. So this inner layer has a heat. And this is not only a one source that decides that asthenosphere is so-called liquid state or so-called that much temperature. There is a one more thing that is more important. Radioactive decay. So radioactive decay. What is this radioactive decay present or happening in the asthenosphere? Because many minerals like uranium, remember the minerals that are important, uranium, thorium, okay, uranium, thorium, potassium, mostly ischium, okay na? So potassium, these are all the minerals, those decay, so they lay between the crust and mantle. They are staying between crust and mantle. Between this layer they melt themselves, so they go on continuous reaction because of the already present temperature, which is more than 1300 to 1700 degrees Celsius. So this energy or heat also instigate this process, and also more radioactive materials continuously decay, and this produces extra amount of heat that keeps on this asthenosphere to be in a liquid state, or that much heat to be present over there. Okay, now you know radioactive decay is happening. This is the main source of so-called liquid state or heat or temperature. Okay, this is safe and happy. And next, if you come to the other things, see here, this is highly viscous. So viscous means what? As I had said earlier, remember the so-called honey which is viscous, and also this is weak. So this will be weak and ductile, which means ductile means this may change its form. It may be solid to liquid, but strength will not be lost. It will be as strong as previously found. Okay, and now we need to know how it helps. So okay, now you need to know how this asthenosphere helps. Really, asthenosphere, is it necessary? Okay, asthenosphere, is it necessary or is it needed, and how it could help the so called earth? Here, when we are studying the solar system, when we study the solar system, only when we are studying the whole solar system, only earth has the asthenosphere. Okay, earth has the asthenosphere layer, so that only the plates over it float. So the asthenosphere has a lithosphere floating over it. So lithosphere, okay, lithosphere floating over it. Below the lithosphere, up to 80 to 200, approximately 80 to 200 kilometers, there will be a so-called asthenospheric layer, and also beyond that depth, it may reach up to 700 kilometers. That is the layer where asthenosphere lies inside the earth. Okay, so the lithosphere floats. So lithosphere floats on the asthenosphere. Because of the floating only, we have all the stories so called as the plate tectonics. So importance, you see, plate tectonics is a major important for the so called asthenosphere. So the plate tectonics theory will be completely failure if the asthenosphere is not present. So this is happening in earth because of the asthenosphere. Okay, and next, see here, volcano lava. Okay, volcano lava is also is a major source where I can see asthenosphere is emitting its energy outside. Okay, now how you detected the so called asthenosphere, how you detect, okay, asthenosphere, how it could be detected, how it could be detected, how it could be detected. After the detection, I will say one more important features of the asthenosphere, which is more important, that I will be including the last end of this class, so that you will be having a clear cut idea. No issues. Here, volcano. So here, volcano is a direct example. Volcano is a direct example for the presence of asthenospheres beneath the lithosphere, so that we have to experience the so called liquid molten lava coming outside. Okay, okay, other forms of detection, how the asthenosphere can be detected. One of the other form is seismic waves. One, lava, you know, that is no issues. Then other thing is seismic waves. Seismic waves are the major source where you can detect the asthenosphere. How could you say that seismic waves can detect the asthenosphere? Here, p waves, you need to know the features of the waves. P waves means travel through all medium, travel through all mediums. This travel through all mediums. So p waves travel through all mediums. Okay, no issues. Which means what? All medium means what? Gas, solid and liquid. Okay, solid and liquid, all the mediums so called as you see the sound similar to the sound, p waves can travel. But s waves cannot travel through. What is the feature of s waves? S waves only solid. S waves is like water which flows only through single medium. Okay, so it flows like waveform, but this is only flows through or passes through solid. Now when I send this, see here, let us consider earth is like this. Here there is a asthenosphere liquid layer, but this s waves cannot pass through. If I send a s wave like this, so it will not pass beyond this. And next, so that I can know that there is a liquid layer present beneath that. So and also based on the travel time distance, we can find that how much distance it is also found over inside the earth. That is no issues. But here, but when s wave sent, so we know that s waves cannot pass through asthenosphere. One other thing, when I send p waves, it will be deflected because the change in medium. Why deflected? So deflected means it is a refraction, it is a refraction happens to the p waves. So this indicates what is the refraction of the p waves tell you? It tells us that is clear that there is a change in medium, so change in medium. So the change in medium is none other than some liquid layer is present. So first p wave shows us there is a change in medium. S waves proved that there is a so called what we say as a liquid layer, because S waves cannot pass through the liquid layer. Okay, now we shall understand so called plate tectonics is also possible because of that. So the importance of the so called asthenosphere we had seen in clear that plate tectonics I had explained. Okay, no issues. Volcanoes and also how we detect. Okay, detection also found out, because we cannot dig and detect, guys, we need to experiment and detect. And also one more thing here, why lithosphere floats. Okay, why lithosphere floats, come on guys, think of once, why lithosphere floats on asthenosphere? On asthenosphere. Why should it float? Can it get dipped inside it? For example, this will provide a clear-cut clarity for you in a plate tectonics, continental drift theory. Everything will be understood just because of this. Whatever topic I'm saying over here. Here, see here, density. So density is a tool that creates that lithosphere floats on the asthenosphere. How could it be, sir? Actually, you need to think of one thing, guys. Did you remember the water? So above the water, there will be ice cubes. So and also ice cubes will be floating on the water. Ice cubes are solid state, but water is liquid. Solid should get inside the liquid, but it's not. It's floating. And another thing, if you see Antarctica regions, there will be a floating icebergs, and also Greenland region floating icebergs. How could these so-called ice cubes can float on the liquid? So here difference of density. See here, solid state. Okay, ice. Okay, ice is less denser. Ice is less dense than water. Water is high dense. Water is highly dense than the so-called ice, high dense. So this is why it floats. Similar concept we need to apply for what? Here asthenosphere is liquid. Okay, so lithosphere is less dense. So lithosphere is less dense, and asthenosphere is highly dense. So asthenosphere is highly dense. So it has high density. But here, without words or facts, you can say that, sir, give me the fact study so that I can believe that lithosphere is less dense. So if you compare the lithosphere density, it is up to 2.7. So it is up to 2.7 grams per centimeter square on an average, which is I'm providing is average density of the lithosphere. But when you compare the asthenosphere, it is greater than, so it will be 3.3 grams per centimeter square or greater than that. Mostly mantle, if you take a mantle, so the mantle density varies from 3.3 to it will be 5.7. So whenever you getting inside, so slowly you are getting inside the earth, you will be experiencing high density. So obviously asthenosphere is in liquid state, but it has high density, so that only we are floating on the so-called lithosphere. If not so, we would have never experienced volcanoes, earthquakes, or human existence, mountains, everything. Whatever the geomorphology you are studying on this whenever you are studying geomorphology of the topic called geology, there won't be without the asthenosphere. The asthenosphere has a major role in the so-called system of geomorphology. Okay, geomorphology here. Next, another thing we need to find here. Do you know that Earth has magnetic field? Earth has magnetic field. So Earth magnetic field. How Earth got its magnetic field? There are the two reasons that Earth got its magnetic field. One is convectional current. So convectional current that is passing through the so-called mantle. So the convectional current and plus the see here the convectional current is like a dynamo. You know, the process like dynamo. Okay, dynamo where the system happens in the dynamo. The similar process happens in the so-called convectional currents, and also the electricity and the charges are created, and also similar way you can experience the so-called magnetic field on the earth. And also the earth's magnetic field is formed because of convectional current plus Coriolis. Okay, Coriolis force. So Coriolis effect. These are the two reasons why earth got its magnetic field. Now you would have a clear cut idea that without convection current, there won't be earth magnetic field. Without asthenosphere, there won't be convection current. So obviously, it is proven that asthenosphere has a major role in even earth getting its magnetic field. And also, what is the composition of the so-called asthenosphere? The composition is mostly iron, magnesium. Okay, iron and magnesium are the important combinations of the so-called asthenosphere. And other than that, there is a little amount of silicon. Okay, silicon is the third element which is dominant. So mainly iron and magnesium, and next comes the silicon, which is the combination of the so-called asthenosphere. Okay students, this asthenosphere is why more important, means this is one of the unsung hero of the earth. So this is the unsung hero of the earth. So here we know the earth structure, internal structure, everything. But if there is no asthenosphere, there is no life on the earth. I see that because this is one of the unsung hero. Because let us see the importance of the asthenosphere. Already I had explained everything in brief. We shall see in brief here. No asthenosphere. See here, importance of asthenosphere means this is the reason why earth has a tectonics. So plate tectonics is possible only because of the so-called asthenosphere. Tectonics is the reason for all the landscapes what we see, so-called minerals, plant, and also we can see that hill, mountains, everything is because of the plate tectonics. There is no volcano without so-called asthenosphere, no volcano. Okay, and also no volcano, and also this volcano is a material which is helps us study the inner of the earth, inner core. So even inner core of the earth can be studied because of this volcano. This volcano is from asthenosphere. So indirectly this asthenosphere is the main reason for the studying of the inner of the earth also. And here asthenosphere is the main reason for electric convection. Okay, convectional cells. Okay, convectional cells, and also here magnetic field is created and many other things. And also minerals, more mineral resources. For example, many minerals that are attained on the surface of the earth are because of the volcanic eruptions. So this volcanic eruption is brought from the asthenosphere, which has been came to the surface and floated along the surface of the earth. And also here all the variations that you see, geomorphological changes, everything is just because of the asthenospheric layer which creates or keeps on earth plates to be floating. Okay guys, let's have a brief review what we had read in clear. Asthenos means weak, and this is below the lithosphere, upper mantle and lower mantle. Between them there is an asthenosphere. It is viscous, which means a honey like fluid flows, and the temperature is very high, 1300 to 1700 Celsius. And also primordial heat. Why it had attained the heat means primordial heat means during the earth formation, where earth is like a burning ball. So from there, and naturally that heat has been cooled down on the surface, and interiors are still on heat. So this is a primordial heat that is present. Another heat that helped to the boosting of the temperature of the so-called asthenosphere is radioactive decay, because of uranium, thorium, potassium, and crust, and other metals between minerals between crust and mantle. And then high viscous, weak, and ductile is the features of it. And next, asthenosphere, you consider that it is only on earth. When you compare to the other solar system planets, only earth has the asthenosphere. This itself indicates that there is a chance that this is the reason why earth has the lives also, because this is a major difference between the other planets and earth, no? So that can be the reason. Lithosphere is 18 below lithosphere. Asthenosphere is present 80 to 200 kilometers depth, and it is floating. So lithosphere is floating above the asthenosphere. Plate tectonics, volcanic lava are the direct examples. And also here why it could be detected, how it could be detected means mainly seismic waves, P waves, and S waves are the major examples why we had detected so-called this asthenospheric layer. And next, the deflection means change in medium can be detected based on the S waves. And here volcanoes are the direct examples of the asthenosphere. And here why it floats, because asthenosphere, this lithosphere floats on the asthenosphere because of the change in density. As we seen, ice and water, same challenge. Lithosphere is 2.7, which means overall density I'm seeing. It may vary 2.5 as such, but asthenosphere is 3.3 and more than that. So and also earth magnetic field is because of convectional current inside the mantle that is happening, and Coriolis force which is externally. Both are combined to create earth's magnetic field. So this indirectly has the stance as the main reason for the earth's magnetic field. Iron and magnesium are the main components. That little components of silicon can also be found here. So one of the unsung hero of the earth is asthenosphere, which stands as a major and important part of the earth. This is where most of the students make mistakes, because understanding the asthenosphere only can create understanding the plate tectonics and continental drift. Most of the students don't understand the continental drift theory and plate tectonic theory and many other theories. For them, I suggest them this video will be the best example for you to understand such subject. After understanding the asthenosphere only, then you can study the other subjects. Then you'll have a clear-cut idea of the earth's interior and surface. Okay guys, this is it for the day. We'll be joining with the next more important topics. This is me, SPR, signing off. Have a nice day.